Thank you for joining me. I'm glad you are there. Today, I want us to look at the topic scalars and vectors. We can always say that a scalar quantity is a quantity that has only magnitude but no direction. So those scalar quantities are only represented by their numerical values. That is why we say that they are expressed only by their numerical values. For example, a temperature of 100 degrees Celsius is just a number. It's measured in a scale. No direction is specified. Or if we see a speed of 20 meters per second in a straight line or along a circular path, we have not given it any direction. So we are just talking about scalar. So we say that a man moves from 10, or if a man moves 10 kilometers, and not the rest of them, we've not given any direction. So that is why we say it is a scalar quantity. So we also say that scalar quantities have no direction. So these ones, no direction was indicated. Since no direction was indicated, so we said that they are all scalars. Then by addition, scalars can easily be added or subtracted by ordinary algebra. Example, we can say areas of 10 meters squared plus 12 meters squared, which can always give us 22, or areas of 5 meters squared plus 12 meters, which is 17. You can always say volume of 3 meter cube plus volume of 5 meter cube, which will always give us 8 meter cube. So for scalars, it's just 1 plus 1, simple. Now, examples of scalar quantities include mass, length, or distance, speed, work, energy, area, volume, density, temperature, time, frequency, etc. and etc. So these are scalar quantities. They have no direction, just numerical values, or only size. With their size, you can tell what they are. Now, on the other hand, we have vectors. Just as scalars, they have only magnitude but no direction. Vectors have both magnitude and direction. For example, a velocity is speed measured in a specified direction. For instance, if we say a car moves due east at 50 meters per second, we have given it the direction, which is due east or due north. Now, the magnitude there is the 50 meters per second. Now, if we say that an aircraft flies 100 kilometers per hour in a northeasterly direction, the direction now is northeasterly, while the magnitude is 100 kilometers per hour. Now, on the aspect of displacement, we can always say that displacement is distance measured in a specified direction. For example, a man runs from Abuja to Lagos covering a distance of 200 kilometers. Now, the magnitude there is the 200, while the direction is from Abuja to Lagos. Okay, just like scalars, which can always be added by an ordinary algebra, but for vectors cannot be added or subtracted by ordinary algebra. It can be added or subtracted by either using geometric method or scale drawing method. By next lesson, I will describe what this scale drawing method is. Now, it is worthy of note that the magnitude of a vector is represented by the length of the line, while its direction is specified by arrowhead. Assuming we have a line like this, let's say the length of this line, if it is 20 centimeter, if it is 20 centimeter, that is the magnitude. The direction is given by the arrow. We can always give the direction in this if it is due west, which is like this. It can always be due north. If it is like this, it is due north, or due south, pointing downward, given the direction of the line. Okay. we talk about addition of vectors. Here we say two or more vectors acting from a point. It can be two vectors, it can be three, it can be more than that. Acting from a point in a body, in any given direction, can be added to give a single vector. And that single vector is called resultant vector, R. Now we can say that a resultant vector is that single vector which would give the same effect in both magnitude and direction as the original vectors acting together. For example, of course, this is just a single vector. Is like adding two vectors to give one vector. So we're not going to look at this resultant vector. For example, if two vectors P equals 30 Newton and then Q equals 40 Newton, acting from a point. If they're acting from a point, let's say 0, the resultant can be obtained. The resultant can be obtained with respect to any of the following. Can be obtained with respect to any of the following conditions. Now we look at case 1. Case 1. If P and Q act in the same direction, if they act in the same direction, assuming this is the point, let's say point O. Now, if they act in the same direction, we have it like this. Let's say these are the two forces, P and the Q. Now, the resultant vector R can be obtained. R is equal to P plus Q, which will give us, and of course, from here, we have that Q is 40 and P is 30. So we have 30 plus 40. Therefore, the resultant vector will give us 70 Newton. Now, this is for case 1, if they are acting in the same direction. Now, for case 2, if P and Q act in the opposite direction. If they act in the opposite direction, this is the point. Now, assuming one is acting in this direction and then the other one is acting in this direction. Let's say P here and then Q here. We can always get the resultants. The resultant R is equal to, now from the Cartesian plane, we know that this is positive, this side is negative. So we can always say P, since P is here, Q minus P. Now Q is 40. 40 minus P, P is 30, which will give us 10 Newton. On the other hand, because you are not restricted to place your P, you can place your P anywhere. You can place your P like this. For instance, if Q is placed here and P is placed here, and of course, it's still the same thing. R is equal to, maybe you pick this value first. If you pick this value first, which is 40, and of course here is negative, so you can say minus 40 plus P. P is 30, which will now give us minus 10 Newton. And it's still obtainable. It can be obtained in any of the two scenarios. Now, case 3. If P and Q are equal, If P and Q are equal, let's say P 30 Newton, Q 30 Newton. So in that case, then if that is P equals 30 Newton and Q equals 30 Newton. So in other words, we cannot have, this is the point of action, 30 like this. Let's have the other one is still, the same they are equal. 30, 30. Let's say P here, this one Q. In other words, we can now say R is equal to Q minus P. And it will give us 30 minus 30, and 30 minus 30 will give us 0 Newton. Now, in this case, if they are equal, it means that the body is said to be in equilibrium. Okay, we'll look at case 4. Case 4, assuming the two bodies are acting at right angles. So case 4, IV, if P and Q act at right angles. If they act at right angle, that means we'll have this, we'll have this. This is our, you can place your P here, you can place your Q here. Now, at this point, an angle is involved. We will not use the other arithmetic, the other algebra. The algebra we used here, which is this plus that, Q plus P, Q minus P, we will not use it. Now, because an angle is involved, the resultant can be gotten by completing the parallelogram. You put a diagonal here. This diagonal gives us the value of our R. Now, already, because this diagonal is here, an angle is formed here already. So we are going to look at these two things. The first one is the resultant, and the second one is this angle. Now, for the resultant, we use Pythagoras theorem. By Pythagoras, we have that R squared, and of course, we will now have this angle here. This is the hypotenuse, and then of course, we'll have the opposite here. So we have this side and this side. So R squared is equal to this side, which is P squared plus Q squared. So R itself will now give us square root of P squared plus Q squared. Okay. Now, let us put values here. Now, since we said P is 30 Newton and Q is 40 Newton. Now we can calculate the resultant using this formula. And it will now give us R is equal to the square root of P. P squared is 30 squared plus Q. Q is 40 squared. Now, square of 30 is 900. 900 plus 1,600. Square of these, the two of them now give us 2,500. And 2,500, the square root of 2,500 is 50 Newton. Therefore, the resultant of the two forces acting at right angle is 50 Newton. Now, for the direction, we can bring this triangle outside. So if we bring this triangle outside, we'll have something like this. We'll now have this as our angle. This, remember to put the arrowheads, this is our resultant. The resultant now is 50 Newton. This side is 40 Newton, and this side is 30 Newton. Now, because our interest is on this angle phi, we have the hypotenuse, we have the adjacent, and we have the opposite. Now, because we have these two were given to us, no need considering this one. So we now have tan phi is equal to, of course, tan theta is the opposite over the adjacent, which will give us, the opposite is 30 all over 40. And of course, 0 can cancel 0. If 0 cancels 0, we now have that tan alpha is 3 over 4. And by calculation, if you press your calculator, 3 over 4 will give us 0.75. 0.75. Now, alpha, which is the angle we're looking for, is the inverse, tan inverse of 0.75. And the tan inverse of 0.75 will give us 36.9 degrees. Also, we can get the direction because we are not under any obligation to put your P here and Q here. Someone else can still put P here and put Q here. In other words, this signs will change. So if it changes, that means this thing will not change. We'll not have that. So alternatively, we can have tan alpha if we swap this, 40 will be here, 30 will be here. We'll now have 40 over 30, which will give us 4 over 3 will give us 1.33. So the angle we're looking for, alpha, is the tan inverse of 1.33. And the tan inverse of 1.33 will give us 53.1 degrees. So we now have two values. So in other words, the direction is either you use this or this. Any of these two values will go as the direction. In other words, instead of taking this, you can still say 90 minus 36.9. And of course, that 90 minus 36.9 will give us 53.1. So this is another way of finding it, because from here to here is 90. Since we have gotten one, we can still subtract to get the other one. So these two are the directions we have. Alright, this is where we will end the lesson today. Thank you very much. Please make sure you subscribe to this channel so that you have access to subsequent videos. Thank you very much.